So thank you, Mishra, and hello everyone. So Mishra, we do have a sales vacancy, so if you're up for it. Okay. So let me first introduce myself. I'm Adé Mochtar, I'm CTO of Instruqt. And as a CTO, as CTOs do, we focus mostly on the technical side, right? But also I have a keen interest in learning, and especially learning new technology. And that's really what Instruqt is about. So Instruqt is an online IT learning platform. So what does that mean? We have the ability, the capability to spin up sandboxes with real infrastructure. And it can be anything from containers, virtual machines, Google Cloud projects, AWS accounts, anything that you want or that you need to run your software and teach it to your users. And in these sandboxes, we are able to spin up challenges to provide our users, to make them think a little bit about your product, and to let them experiment hands-on. And while doing it, we actually validate that what they're doing is correct. And if they get stuck, we give them a little bit of a hint to move forward. So how does that look? If you go to instruqt.com/HashiCorp, you'll land on a page like this, where you see a couple of tracks, as we call them, down there. And these tracks are all about console. So you can learn a little bit about console, Connect, for instance. You can even go to the hub, where there are a bunch of our tracks used as demos. And if we click on one of these tracks, you get dropped into this sandbox environment where we show you a running console instance, which we have pre-populated with some services and a certain scenario and a certain task we give you to solve. And before I continue, I want to just say that it's nice to be back here at Westergas, because actually back in 2016, we did the first HashiConf EU here in Amsterdam. And as Zebia, the parent company of Instruqt, we were co-organizing. And that's where we actually got the idea for something like Instruqt. So what we did is we created a Hashi contest around the 4 major tools of HashiCorp. And we said, hey, we need to challenge these users a little bit, give them the tools, and let them play around with it. And we called it the Hashi contest. And one of the cool things was that we got a lot of feedback that it's really cool as a competition, but also as a really effective learning tool. So that's where the seed got planted for Instruqt. So who was here at 2016 HashiConf? I see a couple of hands. Are you on the leaderboard? So this is the leaderboard, the overview that we had. It was really fun. So how did we build Instruqt? So we mainly build on these great technologies. So we have Kubernetes, we run Terraform, of course, and we use a lot of Golang. And this talk is mainly going to focus on Terraform. We use Terraform basically everywhere. It not only manages our platform, so of course we run on GCP, we spin up a lot of infrastructure, we use Terraform for that. But we also manage all the user sandboxes. So every time someone starts our tracks, we spin up a sandbox, and we use Terraform for that. And we even have tracks that teach you about Terraform. So more visually, it's Terraform all the way down. But let's focus a little bit on the user sandboxes, because that's where the interesting part is. So as I said, Terraform creates these sandboxes on the fly. And we insert some parameters where needed. So for instance, for the console connect track, we insert some configuration about which container to run. So we have a console container, we have some environment variables, some ports to expose, all stuff like that. To give you a little bit of an overview on how that looks. So we create a Kubernetes namespace. Inside that namespace, we can run several pods. We have some configurations, some secrets. And we can also spin up some other infrastructure that's linked to it. So we can spin up VMs, we can spin up GCP projects or AWS accounts. And all that is exposed through our proxy to the user that's playing our tracks. But how does Terraform actually know what to build? For that, we use Terraform modules. We use these modules to basically create an abstraction around the infrastructure that we spin up. And as I said, we support several different infrastructure components, ranging from containers to virtual machines to actual full GCP projects and AWS accounts. And to give you an example of what's required for a container, these are typically the parameters that you want. We want to give it a name, which is also used as the host name, which image you want to use, so it can be a Docker Hub image, can be something from a private registry, how much memory does it need, a list of ports to expose, and also a map of environment variables that are available. However, up until Terraform 0.11, we relied on Golang templating to inject these parameters. So how did that look like? We have a Terraform resource. In this case, it was a replication controller. So back when we wrote this thing, there was no Kubernetes deployment resource yet. So we used the replication controller. And we had a bunch of Golang template syntax in there. So I've highlighted this in red, where we basically range over a list of environment variables and inject them as blocks in our Terraform configuration. And again, because we can spin up multiple containers, we also had to template out the module. So again, I've not taken the effort to highlight it as red, because it's basically one big template. But since we generate the module, we also have to generate the source location. So this is a lot of Terraform generation. So luckily there's Terraform 0.12, which can simplify things a lot. Let me show you. There's 3 features that really help us with this. So the first one is the complex types. So before 0.12, you could use strings, lists, and maps, but that was really limited. In 0.12, we get arbitrary complex types. And best of all, they are also usable as module inputs and outputs. So how does that look like? We define our variable, in this case for the container, which is an object, and we basically specify all the parameters I just showed you. So this is nice, clean syntax, good readable, a lot better. So before, this used to be 5 different variables, much more difficult to read. The second one is the ability to generate dynamic nested blocks based on the very type definition that you just saw. So how does that look like? So in this case, I've upgraded my replication controller to a deployment, but I've also added some dynamic blocks based on the container environment. So the good thing is we no longer need templating of our Terraform code, which is a big help in also validation of Terraform code. So we now can actually run Terraform validate. It will say sensible things rather than struggling with all the Golang templates, which is a nice benefit. And lastly, the improvements on the conditional operators. Especially the lazy evaluation is very nice, which I've used over here. Previously, the memory was a separate variable which had a default value. With complex types, that's not possible to have a default value for one of the sub-values. But luckily, there's a conditional operator which says, if this parameter is null, we can specify a default value, in this case, 128 megabytes. So we succeeded in removing all the templating from our module. Basically, this changed. So we still have a lot of templating here. The good thing is we no longer need to generate our modules. We can use a predefined module as a source, which is really cool, but we still have a lot of other parameters that need to be templated. But luckily, there's more, eventually, I hope. So resource and module for each can simplify things even more. This is not currently part of 0.12, but it will be released soon, I hope. So what we can then do is basically get rid of all our templating, switch to a simple for each statement in our module definition, and basically move all parameters to either a TF-vars file or pass it in command line using JSON or something. And once we've done this, we basically remove all templating needs from our system. So I'm hoping for a later this summer, but hey, you never know. So Terraform 0.12 for me is not just about the configuration language. It's also about simplifying workflow. And there's a couple of things I want to highlight because it really makes your life easier. So first of all, upgrading Codebase is very easy. So big props to the team in creating the tooling and the documentation because it really helps you upgrading your configuration. So basically what I did is I ran Terraform 0.12 upgrade and it handled most changes. So I only had a few things that I need to update manually, but that was mainly because I didn't read the docs and didn't follow the steps. I should have upgraded my plugins, my providers, before I actually ran the upgrade. So don't be like me, just follow the steps, and probably you won't need to change anything manually. What's also very useful is the context-rich error messages. And I'm going to give you a couple of examples. And the reason why this is very helpful is because you're most likely, when upgrading to 0.12, you're going to use the new complex types for your variables, meaning you will have a lot of variable references that are no longer valid, and Terraform can really help pinpointing those. So it really says, on this line, you have this error. This really helps in basically testing out your module and upgrading your source code. So another challenge we used to have before 0.12 was reading Terraform plan output. These are a couple of examples. So I have two resources that are being changed. One is a config map in Kubernetes, which contains some JSON structure, and the other one is a list of services. So both are not instantly obvious what's going to change. So you really have to, well, this is a fairly small example of a JSON structure, but I've seen, well, very large structures, and you need to basically copy this out and do a manual compare, which is really a pain in the ass. And also, if you have a lot of properties that are being updated, it's not instantly visible what's going to change. So luckily, there's also Terraform 12 to the rescue. And especially the JSON diff, as I'm going to show you, is really wonderful because this will help you and save you a lot of time. So what they do is they basically they structure the JSON and tell you which property of the JSON is going to change and how it's going to change. And this is much more readable, and this is going to save you a lot of time. And also for the services, the list of services, it's much more clear which services are getting added or which one are going to remove. Yeah, big save on time. Then something I want to talk about, it's not necessarily related to 0.12, but I think it's a very interesting topic because we run a fairly untypical use case for Terraform. But handling state, this is something that you can do, right? But I think there are better options. Let's go back to our platform. So we have the platform where we basically run our core infrastructure, the core services, our Kubernetes configuration, all the DNS configuration, all stuff like that. And these changes are very infrequent. But once we change them, these changes can be very high impact. So what we really want here is a good peer review, is a good workflow around it to validate that the changes that I'm making are the right changes and that the team member of mine can actually verify that I'm doing the right things. So currently we store our state in GCS buckets, which sort of suffices, but we don't really get anything for the collaboration features. And that's where I think Terraform Cloud and Terraform Enterprise come in, because they offer some really good collaboration features on running complex plans on your infrastructure, so you can be more sure about the changes that you're going to do, that they're not going to break anything, because that will make your users very sad. So just a quick example, I took this slide, this picture of the website. I don't have a running example for you, but the fact that you can have a discussion around Terraform plans, much like you would in a GitHub pull request, is very helpful. You can have a double check whether you're not destroying something that you shouldn't, which is really helpful. And then our user sandboxes. And this is where things get interesting state-wise. Because every sandbox that we create is basically a Terraform run. And because we create sandboxes for every user that plays one of our tracks, these runs can and thus will be executed concurrently. And that creates a whole new set of problems that you don't have if you just have a single plan that you apply. So our first idea was, let's run these, or let's store this state in a GCS bucket in a subdirectory per sandbox. Easy, right? So you just have, you just do the Terraform init with a backend configuration. You specify a prefix. We insert one of our sandbox IDs, and we're done, right? Yeah, so we thought. We ran this for a while, and all looked well while developing. But once we rolled this out to production, we got some interesting results. So some users were saying, hey, this sandbox that you gave me, it's exactly the same machine as my neighbor got. And we were like, no, that's not possible. We spin up a sandbox for you, just for you. It's unique. You should be the only one to access it. But still, they say, well, yes, we are. Look here, I'm touching a file, and the other guy can see it. So that was really weird. So what happened is that the configuration of which backend you use or which workspace you use is still local to your Terraform run. So what you need to do is to prevent these shared sandboxes is that every Terraform run must be initialized in a separate subdirectory. Because otherwise, you will just refer to a similar state, to the same state file, and you will override which backend you're using, your backend configuration you're using, and you get basically partial applies where you can share sandboxes. So our fix basically is simple. We already have the unique sandbox ID. Let's make a temporary directory to store the Terraform state in, and use that to initialize Terraform. So another interesting use case or problem we ran into is at high concurrency or high load, sometimes these remote state backends fail, which is really interesting, but also quite annoying. And we get these vague error messages like TLS handshake timeout, IO timeouts. And this is really annoying because we really rely on these Terraform runs to be successful to spin up these training environments. It's not like, hey, I did my apply for a infrastructure change and I can do it again if it fails. No, there's actually people waiting for this sandbox and we preferably have it up and running in a couple of seconds. So when this fails, this is really annoying. So we started looking at some alternative backends. Mainly two. It's the HTTP backend. It's a slightly lesser known backend. And the remote backend as part of Terraform Enterprise or Terraform Cloud. So first, let's look a little bit at the HTTP backend. The cool thing is that you can implement this yourself. So the only thing that you need is a REST server that supports a get and a put and a post and a delete. And you can nicely integrate it with the rest of your infrastructure. So the cool thing is you have one less runtime dependency in your infrastructure. But it does require some custom work. And then we have the remote backend. In the remote backend, the cool thing about that is that you don't need to customize anything. It just works out of the box. You get a nice API you can talk to. So it's part of Terraform Enterprise. So that really is also something that's interesting to use because you don't need to actually do anything for it. But we chose the route of the HTTP backend. And we've just started implementing this. So documentation for this is very limited. It's about limited to what's over there. State will be fetched via get, updated via post, and purged with delete. And that's about it. But luckily, with some reverse engineering, with some other examples we found on GitHub, we have a working implementation. I'm not going to show it here. If you're interested, come find me afterwards. I can walk you through what's necessary. But the cool thing is, it's only about 100 lines of code. And that's because we already have a lot of the infrastructure in place. We have our backend. We have our backend system that we can plug this into. We already store a lot of information about these sandboxes. This is just another field in our database with a large JSON blob. So that's really cool. So let me get to my lessons learned. In my opinion, Terraform 0.12 is really, really powerful. It makes the language a lot more powerful, a lot more readable, a lot less strings to look at, but much more clean syntax, and especially the for loops, the complex types make it a really powerful language. And even that, it still maintains the declarative side of things. So it's not a full programming language. So I think it's the best of both worlds. Terraform 0.12 also provides a lot better feedback on plans and on errors. And especially if you're going through an upgrade scenario, this feedback is very welcome. You're going to be changing a lot of things, and every second you can save by having a better error message is all valuable. And finally, I'm really a fan of Terraform Cloud's collaboration features. I can't wait to start using them in production for our platform. I got a chance to look at it, to play around with it a little bit. But I'm really excited about starting to use these things. Cool. Thank you.